Hello everyone, myself Sadananda Gowda. In the research paper, I was chosen the topic Hadoop, Hadoop Distribution File System Basics. Subject is Big Data Analytics. Subject code is 21CS71. Subject title is Hadoop Distribution File System Basics. My USC number is 1VE21CS147. The Hadoop Distributed File System. Hadoop distribution file system is designed to reliable store and stream very large dataset at high bandwidth. It distributes storage and computation across thousands of commodity servers in large clusters, allowing for economic scaling. This paper describes the HDFC architecture and reports on its use at Yahoo to manage 25 petabytes of enterprises data across 25,000. HD Hadoop Distribution File System Architecture Overview. Hadoop Distribution File System as a master-slave architecture. The name node is the master that manages the file system namespace and regulates across to file. Data nodes are slaves that stores and retrieve blocks of data. Files are split into larger blocks, typically 128 MB, which are stored on data nodes. The name node executes file system namespace operations and determines the mapping of blocks to data nodes. Data nodes handle read and write requests from clients and perform block creations, deletion, and replication upon instrument from the name node. Name node and the data nodes. In the name node, manage file system namespace, and name node also regulates file across accesses. Name node determines the block to data node mapping. Data node. Uh, Data node stores data blocks, handle read and write requests, perform block operations. Name node operations. The name node stores metadata like the namespace hierarchy and block locations in memory for fast access. It records persistent checkpoints and journals of the namespace challenges. During the setup, it loads the latest checkpoint and replaces the journals to recover the namespace state. The name node is a multi-thread system that handles client request concurrency to optimize performance. It batches the multiple transaction when writing the journal. First one startup, second one the normal operation, third one checkpoints. In startup, load latest checkpoints and replay journal. Second one normal operation and client request and namespace changes. Checkpoint periodically create the new checkpoint. Data node operations. Data nodes store each blocks as two files in their local file system, one for data and one for metadata. They connect to the name node at the startup to perform a handshake verifying namespace ID and software versions. Data nodes then register a periodically send blocks reports and heartbeats to the name node. Heartbeats confirm data nodes health and carry storage statistics. The name node responds with instructions like replicating or deleting blocks. Data nodes also run a block scanner to verify the data integrity. First one startup, second one normal operations, third one block management, fourth one integrity checks. In first one startup, handshake and registration. Second one normal operation block reports and heartbeats. Block management, third one block management. In block management, replication and deletion. Fourth one integrity checks. In integrity checks, block scanning. Hadoop Distributed File System Client and Data Flow. In Hadoop Distributed File System, client provides a file system interface for applications. For reads, it fetches block location from the name node and reads directly from data nodes. For writes, it gets data node location from the name node and writes directly to the pipeline of data nodes. The client computes the checksum for data blocks. HD Hadoop distributed file system use rack-aware replica placement to maximize the data reliability and read-write performance. The default policy places the first replica on the same rack as the writer, the second and the third on the different rack, and additional replica randomly. Read authorization clients read directly from data nodes after getting block location. Write operations write operation client writes to pipeline of data nodes after getting. Replication and fault tolerance. HD Hadoop distribution file system provides fault tolerance through data replication. Each block is typically replicated to three data nodes. The name node consistency monitors data node status through heartbeats and re-replications blocks from the nodes that fail or become disconnect. It also balances the replica placement across the cluster. Hadoop distributed file system includes tools like block scanner to detect and repair corrupt data for disaster recovery. Hadoop distributed file system support multiple name nodes and cross-cluster replication. These mechanisms ensure high data availability and durability, dissipate frequently node failures in large clusters. First one replication, second one the re-replication, third one balancing, fourth one integrity. In first one replication, typically three copies of each block. Um, re re replication automatically replace lost replace. Balancing spread reflex across cluster. Integrity detect and repair cor corruptions. Hadoop distributed file system or TIO. Yahoo operates large Hadoop distributed file system clusters with up to the 40 nodes each. A typically node has two quad core processors, 16 GB RAM and 4 TB of disk storage. Clusters store 25 petabytes of data across 20 to 25,000 servers. Totally, Hadoop distributed file system handles millions of files and with 2 million new files created daily. Key applications include the web indexing and user behavior analysis. Yahoo has addressed challenges like name node scalability, resource sharing, and data durability. Benchmarks show read-write spreads of 66 MB and 40 MB as per node respectively. Yahoo startup 1 petabyte of data in under 17 hours using HDFC and map reduce. Nodes per clusters, total storage, total services, new files per day, read speed, write speed up to nodes per cluster up to 4,000. Total storage 25 petabytes. Total services for 25,000. New files per day 2 million. Read speed 66 MB as per node. Write speed 40 MB as per node. Further future work in the HDFC team at Yahoo is working on the services improvements. First one, automated name nodes failures using Zookeeper for highly availability. Second one, name node scalability through federated namespaces and back storage abstraction. Third one, support for smaller files and application centric namespace. First one, better multi cluster cooperation and replication. First one, scaling to larger cluster while maintaining manageability. This enhancement aim to the improves the HDFS scalability, availability, and flexibility to support diverse use case and larger deployments. Highly availability, automated name nodes failure, scalability, federated namespace, small files, and a better small file support, multi-core, improved clustering operation. Thank you. I hope you all are understand.